Something strange just happened to a comet traveling through our solar system. It was not supposed to become this bright, and scientists still don't know exactly what caused it. Comet 220P, also known as McNaught, has suddenly undergone dramatic outbursts that transformed an extremely faint object into something thousands of times brighter than it normally appears. NASA now reports that the comet is roughly 20,000 times brighter than usual, and that number is almost difficult to comprehend. Because this is not a comet that suddenly appeared out of nowhere. It has been orbiting the Sun for years. Scientists know its path. They know its approximate orbital period. They know where it has been and where it is going. But something happened to the comet itself. And now astronomers are watching closely. Because when a comet suddenly erupts like this, the important question isn't simply how bright it became. The important question is, what happened beneath its surface? Comet 220P McNaught is what astronomers call a periodic comet. It follows a repeating orbit around the Sun, taking a little more than 5 years to complete one trip. Its path carries it through the region between the orbits of Mars and Jupiter, bringing it closer to the Sun before sending it back toward the colder outer solar system. This is not an unknown object making its first appearance. It is a returning member of our solar system. And under normal circumstances, 220P is extremely faint. So faint that NASA says you normally need a telescope to see it. That is what makes what happened this year so unusual. The comet didn't simply become a little easier to observe. It experienced 2 separate outbursts, and those outbursts dramatically changed its brightness. The first major event happened around the end of May. Observations reported a huge increase in brightness. Then, after the comet began fading again, another major outburst occurred in early August. That second event pushed the comet back into the spotlight. By August, this normally faint object had become bright enough to be visible with binoculars under suitable conditions, while long exposure cameras could capture its structure much more clearly. NASA's August 24th report describes the comet as unexpectedly bright and says the 2 outbursts this year have made it about 20,000 times brighter than usual. But what exactly is an outburst? To understand that, we need to stop thinking about comets as simple balls of ice flying through space. A comet is much more complicated. At its center is a solid nucleus made from a mixture of frozen materials and dust. Scientists sometimes describe these objects as remnants from the early solar system because they preserve material left over from the period when the planets were forming. Far from the Sun, much of that material remains frozen. But as a comet moves closer to the Sun, solar radiation begins changing its environment. Ice and other volatile materials can transform directly from solid into gas. That gas can escape from the surface. Dust can be carried along with it. And around the solid nucleus, the escaping material can create a much larger cloud called a coma. Further away from the Sun, material can be pushed into a tail. This is why comets can suddenly become much more spectacular as they approach the inner solar system. But normal comet activity doesn't fully explain what happened at 220P. The remarkable part is the scale and suddenness of its changes. Imagine watching an object that is normally barely visible suddenly brighten by thousands of times. That isn't just a gradual seasonal change. It's an event. Something inside or on the surface of the comet released a significant amount of material or energy, and scientists don't yet know precisely which mechanism was responsible. NASA lists several possibilities. One is the sudden release of gas that had become trapped beneath the surface. Another possibility is something resembling a comet quake, a sudden structural event that disrupts the surface and exposes or releases material that had been sealed away. And that possibility is especially interesting, because a comet may look like a simple frozen rock from a distance, but inside it can contain layers, fractures, pockets of volatile material, and regions that respond differently as the comet heats and cools. Solar heating doesn't necessarily affect the entire object evenly. One region can warm faster than another, pressure can build, gas can become trapped, a crack can form, and then, suddenly, material can escape. From Earth, the result can look like the comet has switched on. But the real event may be happening on a much smaller scale, deep inside the comet's surface layers. And this is one reason these outbursts are scientifically valuable. Every time a comet erupts, it potentially exposes material that was previously hidden. Instead of observing only the outer surface, astronomers may get a temporary glimpse into what is happening underneath. In other words, the outburst itself can become a natural experiment. Scientists can compare the comet before the event, during the event, and afterward. They can measure changes in brightness, they can examine the coma, they can study the dust, they can observe the tail, and they can track how quickly the object fades after the outburst. All of those observations can help reveal what actually happened. And 220P has already given astronomers something unusual to work with. This isn't its first dramatic episode of 2026. the first major outburst, occurred near the end of May. Afterward, the comet gradually became fainter. Then another major outburst occurred around August 4th or 5. Independent observations reported another enormous increase in brightness. Sky and telescope observations documented the August event and described the comet reaching roughly magnitude 6 to 7 after the eruption, before beginning to fade again. That pattern matters, because if the comet simply brightened once and faded, scientists might be dealing with one isolated event. But two major outbursts in the same year raise a different question. Why is this comet becoming active again and again? Is there a particular region of its surface that is repeatedly destabilizing? Is solar heating penetrating deeper than expected? Are volatile gases accumulating underground? Is the comet structurally fragile? Or are several different processes happening at once? Right now, we don't have a definitive answer. And that's exactly where the story becomes interesting. Because science doesn't require scientists to already know the answer. Sometimes, the most valuable observation is the one that forces them to ask a better question. And 220p is doing exactly that. There is another reason astronomers are watching this object. The comet is not simply going to disappear immediately. It continues along its orbit. NASA says 220p will pass approximately 1 Earth-Sun distance from Earth in October. After that, it is expected to fade quickly as it begins moving back toward the more distant part of its orbit. That does not mean the comet is going to hit Earth. It isn't. This is an important distinction. The comet's upcoming passage is scientifically interesting because of its distance and visibility, not because it represents an impact threat. The October encounter gives astronomers another opportunity to observe what happens to the comet as it moves farther from the Sun and Earth. And that could be particularly useful if another outburst occurs, because now scientists have a baseline. They have seen the comet before the eruptions. They have observed it after the first major event. They watched it fade. Then they watched it erupt again. And if it changes again, they can compare those observations. That could help answer one of the biggest questions surrounding the object. Was 2026 an unusual year for 2.20p, or is this revealing a behavior the comet has been hiding for much longer? There is also something fascinating about the timing. The comet reached perihelion, its closest point to the Sun, in June 2026. Its orbital data places its period at a little over 5 years. So this year's activity is occurring during a period when the comet is naturally experiencing stronger solar heating than it does farther from the Sun. That makes solar heating an obvious part of the investigation. But obvious doesn't necessarily mean solved. A comet can respond to sunlight in complicated ways. Two comets can travel through similar regions of the solar system and behave very differently. Even the same comet can behave differently during different passages. Its surface changes, its internal structure can evolve. Previous eruptions can remove material and expose new layers. Cracks can open, dust can accumulate, gas pathways can change. So astronomers cannot simply assume that what happened during one orbit will happen again during the next. And that is why repeated observations matter. Every new outburst adds another piece to the puzzle. There's another visual clue worth paying attention to. NASA's recent image of 220p shows a bright greenish coma surrounding the comet's nucleus, along with a short dust tail. That green appearance isn't the comet literally glowing like a green fireball. It comes from light emitted by molecules and atoms in the material surrounding the nucleus. When sunlight interacts with gases released by the comet, certain compounds can produce characteristic colors. The result is one of the most recognizable signatures of an active comet. But behind that beautiful appearance is a much more violent physical process. Material that may have remained frozen or trapped for enormous periods of time is suddenly being released into space. And in the case of 220p, that process has apparently happened more than once this year. Think about what that means. This comet has spent most of its existence traveling through extremely cold regions of the solar system. Then, during its passage around the Sun, something inside it changed. The comet became dramatically brighter. Then it faded. Then it erupted again. And now astronomers are watching to see what happens next. That is why this isn't simply a story about a pretty comet in the night sky. It's a story about a piece of ancient solar system material revealing that it may be much more dynamic than it appears. Comets are often described as time capsules. They contain material left over from the early stages of planetary formation. Studying them can help scientists understand what the solar system was made from before the planets reached their modern forms. And when a comet suddenly exposes new material, it gives scientists an opportunity to study that material from a distance. We can't land on 220p right now. We can't drill into it. We can't cut it open. But nature may have done something almost as useful. It may have opened a temporary window through the comet's surface. And that window could close quickly. As the comet continues along its orbit, its activity is expected to decrease. NASA says 220P is expected to fade quickly after its October passage as it begins returning toward the more distant portion of its orbit. So this may be a relatively short-lived opportunity, and that is what makes the next few months worth watching. Will the comet erupt again? Will it continue fading? Will another region of its surface become active? Will astronomers identify evidence that points toward trapped gas? Or will the observations reveal something completely different? At this moment, we don't know, and we shouldn't pretend that we do. The strongest conclusion we can make is simpler. Something unusual happened to Comet 220P McNaught. It experienced two major outbursts in 2026. Its brightness increased dramatically. NASA now describes it as roughly 20,000 times brighter than its usual state, and the exact physical mechanism responsible for those outbursts remains unresolved. That uncertainty is not a weakness in the story, it's the story. Because astronomy is often about catching nature doing something unexpected and then trying to reconstruct what happened from the evidence left behind. And 220P has left behind quite a lot of evidence. Its changing brightness, its expanding coma, its dust tail, its repeated eruptions, its movement around the sun, and the timing of all of those events. Put those pieces together and you get something remarkable. A faint comet that most people would never notice has suddenly become one of the more interesting small bodies in Earth's skies. Not because it is heading toward us, not because it is going to explode, not because it is going to destroy anything, but because it is changing. And scientists are watching. That's the part worth remembering. Space is not a static backdrop. The objects moving through it are constantly interacting with sunlight, gravity, radiation, heat, and their own internal structures. Sometimes those changes happen slowly, over millions of years, and sometimes, for reasons we don't fully understand, we get to watch them happen almost in real time. Comet 220P has given us one of those moments. A normally faint object suddenly brightened. Then it did it again, and now astronomers have several months to watch what comes next. By October, the comet should pass roughly 1 Earth-Sun distance from our planet before continuing outward, and if it produces another unexpected outburst along the way, scientists will have another opportunity to study the evidence. So the next time you see a bright comet in a telescope image, remember what you're actually looking at. You're not just seeing a ball of ice, you're seeing a fragment of the ancient solar system. A body that has been traveling around the sun for years. A body that can carry material and structures preserved from a much earlier era. And in the case of 220P, you're seeing an object that suddenly revealed that its interior may be capable of surprising us. 20,000 times brighter than usual. 2 major outbursts, 1 unanswered question, and a comet that isn't finished telling us its story yet. If another change happens, we'll be watching it. So if you want WideView to follow what scientists discover next, subscribe to the channel. Because sometimes the most important discoveries don't begin with something scientists predicted. They begin with something they didn't expect to see. Something changed, scientists noticed, and we'll be here to show you what happens next.